Alright, so our topic today is linear equations, and I'm just going to give you guys an introduction to this. We'll probably be looking at this for a month or so until winter break. So today we're going to talk about first graphing using a T-chart. And a T-chart is sometimes called a table of values. Another term for it. This is what a T-chart is, except this is empty, so we have to fill it up. So we're going to look at this equation. What makes an equation linear basically is two things. We have a y and an x, but we don't have x squared or x to the third or square root of x or anything like that. So we might have a number times x. We might have x divided by a number, but we never have an exponent on x. So when we see an equation that's in this form, y equals something x, and there could be another number added or subtracted, we know that that's a linear equation. Linear meaning, when I graph this, the graph will look like a line. Okay. You don't really have to know that to do your homework. All the equations that I'm going to give you are going to be linear equations. But I will say there's one exception, which we will look at kind of towards the end. So to graph this equation, I have to know some points along the line that I want to graph. Okay? When I'm graphing, what I'm doing is I'm finding solutions to this equation. And you've probably done this part of it before, like in elementary school. What we do is we pick a number. Like let's say I picked the number 0 for x. I would say when x is 0, y equals 3 times 0 minus 7. So y would equal 0 minus 7, y would equal negative 7, and that is what I put in this side of the T-chart. Okay. Then I can erase all of this. What does this represent though? 0, negative 7 represents a point on the line. It represents a solution to this equation. But there are infinite solutions. Yeah? This is a coordinate, and we'll get to that in a second. There are infinite solutions to this. Like what if x were 1? If I pick the number 1 for x, what do I get for y? Well, y would equal 3 times 1 minus 7, which would be 3 minus 7, or negative 4. So when x is 1, y is negative 4. Okay. How many points do you think I need to make a line?
3. 2.
We only actually need 2 points, but I'm going to go with 3. We're always going to want to get at least 3 points, because that way if we messed up, we'll know it. Okay? A line only needs 2 points, right? I can make a line from just these 2 points. But if I get a third point, it should be along that line, right? If it's over here, then I mess something up, because this would not be a line. That would be, a triangle. It wouldn't be a straight line. So what might I do to get my next point? Yeah, totally. Let's pick 2 for x. If x is 2, what's y? How do I know? Okay, how did you find that?
Because 3 times 2 is 6, and then minus 7 is minus 1, and also the pattern.
Okay.
Increases by.
Yeah, I really like what you just pointed out here. If I'm going up by 1 for x, y is going up 3. 3. So if I were to put in 3 for x, what do you think I would get for y? 2. Right? Just 3 more than that. If I put in 4 for x, what do you think I would get? 5. If I put in 5 for x, what do you think I would get? 8. Those are all correct. So there is a pattern using this number in front of x that will help us. Okay, so now how do I translate this into a graph? And this is where we go back to what Jack said earlier. Each one of these rows in this table of values, or in this t-chart, is a coordinate pair. So if x is 0, y is -7, I could write that like this. 0, comma, -7. I could write this one, 1, comma, -4. And I'm just going to graph 3 points. So how would I write this point? 2, comma, -1. Okay. Where is this point on the graph? Okay, it's kind of in the middle. And then down 1, 2, 3, 4, 5, 6, 7. So my first point is, I'm going to use a different color. My first point is right here. Okay? Where is this point? 1 to the right. 1, 2, 3, 4. So I just want to make a point which is my ruler. We could graph this line right now. I could make a line that connects those 2 points. And I put arrows at the end because this technically goes on forever, right? If x were 10, y would be like 30 minus 7, 23, right? If x were 1,000, y would be 2,993. Right? That'd be like way over there and way up there. So I don't want to draw that, so I just put an arrow on the end of my line to say, this line goes on forever. There's an infinite number of solutions to this equation. The other thing I want to say, we've been picking like whole numbers for x and y. We've been getting whole numbers, which is good because it's easy to graph them. But this is also a solution, like right here. This point right here might be, x might be 1.9. And when x is 1.9, y would be 3 times 1.9, or negative, sorry, x would be 1.9, y would be 3 times 1.9 minus 7, which is like -1 or something around there. Right? I mean, there are infinite solutions even on just any part of the line. This part of the line is made up of infinite points. Right? It would be like when x is 2, when x is 2.1, when x is 2.11, when x is 2.111, when x is 2.312456, right? When x is 1.782, all of those points are on this line. I could plug anything in for x, the square root of 17, and I could get an answer for y that's on this line. Does that make sense? So my third point, that's a solution, better be on the line. So 2, -1, it's going to be really close to what I just drew there. Right? 1, 2, down 1 is like right there. Now I didn't do my graphing perfectly, but that's pretty close to being right on this line. Right? If I did 3 points and one of the points was like over here, I'm going to know, wait, I messed something up because there's no line that connects this point and this point and this point.
That's why it's called linear.
Yeah, that's why it's a linear equation. All right, let's take a look at another example. I'll try to leave my grid in here. Okay. So let's graph this one. Let's use a new color. Y equals 4x minus 5. Make my t-chart. Okay, what might I do here? What could I do here? Okay, let's say, what if x is 0? What would y be when x is 0? Negative 5. 4 times 0 is 0, minus 5 is 5. Okay? Is that enough? Can I make a line from one point?
No, you could do 1,
Okay, if x is 1, what would y be?
negative 5, yeah. No,
I'd have 4,
negative.
4 times 1 minus 5, which is 4 minus 5, which is, hey, negative 5 to negative 1, that's 4 apart.
So this should be 3.
Huh. So if x were 2, we'd predict that y would be 3. Let's just check it and see if that's what we actually get. So if x is 2, 4 times 2, what's 4 times 2?
8.
8 minus 5 is 3. So this pattern is holding. This pattern is working. Okay, 3 points is enough to make a line. Let's go ahead and graph these points. Where is 0, negative 5?
On the third quadrant, right? And then it's on the slope line.
Over here?
Yeah.
0, negative 5?
Oh, yeah. No. I was thinking for some reason I thought x and y was switched. It's down. It's down.
1, 2, 3, 4, 5, like that?
Yeah, right there.
Okay. Where is 1, negative 1?
Like right in right.
Just tell me where to go.
Okay.
Go like diagonally
Right
down.
down.
Yeah, like right there.
Yeah.
Okay. And where's 2, 3?
2 over
And
3 up.
Okay. Now these 3 points better all be on the same line, right? And it looks like they are. I'm not doing a perfect job of graphing or drawing my axes, but pretty close. Pretty good. So that's my line. And this is technically all the solutions to this equation. This is my way of showing any possible solution to y equals 4x minus 5. Okay. So if I'm wondering, like, well, what if x is 5? I can kind of look on here and go, well, it looks like y would be maybe, I don't know, 19 or something. But then I could actually check it. Oh, y would be 15. But this line shows me approximately every solution that's possible to this equation. And if you use like an online graphing calculator, if you have a graphing calculator, you can actually like click on the line and drag your point, and it will tell you every single point along that line, which is kind of cool. All right. So I'll look at something a little different now. What if we had red? Y equals negative x plus 3. Step 1, make a t-chart. What's a good number to plug in for x? 0. Okay, what would y be? 3. What's another number I could plug in for x?
1.
1. What would y be?
2.
What's another number I could plug in for x? 2. What would y be?
1.
1. What's the pattern here? Because we're talking about the pattern. This is technically called the slope. So the slope, what is the number in front of x here? It was like 3 and then it was 4. Now it's just negative.
Going down that one.
Yeah, it's going down by 1. Technically, negative x is the same thing as negative 1x, right? So I could say that my slope is -1. It goes down by 1 each time. Okay, let's graph it. 0, 3 is up here. 1, 2 is right here. 2, 1 is right here. And then I can connect those points. And make a line. Okay, questions on this? All right. I'm going to do one kind of variation on this. And I want you to pay attention to something that I've been saying. I've been saying, what is a good number to plug in for x? Right? And I'm going to show you now why I've been saying that. What if we had something like this? Y equals 1/2 x minus 2. Okay, a good number to plug in for x here is still 0. 0 is great because it just gets rid of this fraction altogether, right? 0 just basically eliminates that. So if x is 0, y would be -2. -2. Okay? But 1 is not a great number. It would work, I could do it, but I would have 1/2 minus 2. I mean, it's okay, it's not that hard to do that, but it would be much easier if I plugged in multiples of the denominators. So what if I just plugged in 2 for x? If I plug in 2 for x, y would be 1/2 times 2 minus 2, which equals 1/2 times 2 is 1 minus 2, -1. That's going to be easier to graph than if I had done like 1 and -1.5. So what's a third number that I might plug in?
4.
Yeah, remember I'm going to look for multiples of this denominator. So let's plug in 4. We'd have y equals 1/2 times 4 minus 2. What is 1/2 of 4? 2 minus 2. So y would be 0. So the pattern is that it goes down by 1, except there's something a little different, right? Because I didn't go up by 1 for x. Yeah, when x went up by 2, y went down by 1. No, y is going up by 1, not down by 1. Right? -2, 1, 0. Yeah. So when x goes up by 2, y goes up by 1. That's kind of our pattern. All right, let's graph that. 0, -2 is right here. 2, -1 is right here. 4, 0 is right here. I have a line that's a lot more gradual than the lines that I graphed before. I'm not even going to erase that. Let's just use another color to graph one more like that. Y equals -1/5 x plus 7. Okay. Let's not even solve these yet. What are some good numbers that I could plug in for x? First good number is always 0. Yeah, 0 is pretty much always going to work. Okay? What would be your next choice? 5. Because 5 times 1/5 is just going to be 1. And then what would be the next multiple of 5? 10. Okay, let's plug them in. When x is 0, y would be, 7, right? That just gets rid of that. So 0 plus 7. Okay, when x is 5, y would be -1/5 times 5 plus 7. 5 and the 5 down there cancel, so I've got -1 plus 7, which is 6. Okay? And then the last one, y equals negative 1/5 times 10 plus 7. The 10 cancels with the 5, leaving 2. So I have negative 2 plus 7, which is 5. Okay, now I go to graph this. First point, 0, 7. Second point, 5, way over here, 6. Third point, 10, way over here, 5. And again, those kind of look like they're on a nice line. Okay, questions about that? Great. So I just want to talk about one last thing, and this is kind of extra. Something like this. When would we actually use linear equations in real life? When would we use them? Yeah. 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 Businesses use them all the time. So I'm going to give you 2 examples of businesses that might use a linear equation. One is a taxi cab company. So let's say we had this problem. A taxi charges a fee of $10 per ride plus an additional $1 each mile. So right now I'm not asking you a question, but what I want to show is we could model this with a linear equation. So let's say that the fee, the charge, the total charge is y. Y would equal what? Well,
X
yeah,
plus 10.
okay, yeah. Y is always going to have a 10, right? There's always going to be that 10. We write that kind of at the end. This is like the flat fee because it doesn't depend on anything. No matter what, you get in that taxi cab and you're going to pay $10. There's no variable attached to it. It's always 10. And because of the way we've been graphing these, I like to write that at the end. But then they also charge $1 per mile. So I could write that as 1x. So the total charge is $1 times x plus 10. Now I could have written this differently, right? I could have written something like C equals m plus 10. C being the charge equals the number of miles plus 10. And then if I graphed that, I would just have a y-axis that was actually a c-axis and an x-axis that was actually an m-axis. So we can change the variables. It doesn't really matter.
So you can like change an m, like you can change an x into an m.
I can use whatever variables I want. Now if I have an x, I can't later I can't change it into something else. But when I'm deciding how to write the equation, I can write whatever variables I want to. So if it helps you to think of it like mnemonically, right? C for charge and m for miles, you can. Okay, let's look at another example. So a cell phone company charges $100 per month plus an additional $5 per megabyte of data used that month. And I'm going to put a question here. If you use, if you use 5 megabytes of data, how much will you be charged? Okay, and I know you can probably like go straight for the answer, but I want to first write our equation. So what is our linear equation here? We have to identify which number is the number that kind of changes depending on something. In this case, depending on the amount of data that we use. And which number stays the same. Right? So remember, when we write our equation, we're going to have y equals, the slope is the number that changes depending on the data, x, plus this is the number that just stays the same. Okay, so which number changes and which number stays the same? Okay, raise your hand if you think that 5 is the number that changes that I should put there. Okay? Because we get charged $5 extra every time we use more data, right? So it's changing. Okay? And then what number would go there? 100. Because we're always going to pay $100. One thing to think about is to ask yourself, what if I used 0 megabytes of data? That's like when we said if x were 0, I would just pay $100, right? And you can probably tell that by reading this. What if I got in a taxi and went 0 miles? In that last problem, they still would have charged you $10, right? Just for getting in. All right, so we've got y equals 5x plus 100. Now, I want to find out what is my total charge if I use 5 megabytes of data. So let's think about what the variables represent. What is y representing in this equation? Yeah, this is representing the dollars, right? The amount that I'm paying. What is x representing? Yeah, the data. We could use a d.
The additional cost of
So where am I going to plug in the 5?
You can put that, you're gonna multiply 5x by 5
Yeah.
and add that.
I'm going to put the 5 in right here. So my total charge would equal 5 times 5 plus 100, which equals 25 plus 100, or 125. So I would say something like this. You will be charged 125. Questions on that one?